Hi, this is lesson 2.1 on properties of exponents, and we're going to talk about the way that exponents behave. On your notes, it might say x to the n. I prefer b to the x, but it works the same way here. This b, the reason I like that is because this is the base, the number on the bottom. The smaller number that's raised up to the top, that is the exponent. And so this is the exponent. In this case, n is the exponent, and x is the base. And the exponent tells you how many times the base is a factor. So if we had, for example, 3 to the fourth power, that's the same as 3 times itself 4 times. 3 times 3 times 3 times 3, which comes to a total of 81. I'm going to skip the order here just a little bit. I'm going to move first to this x to the m raised to the nth power. When you have a power raised to, x to the m times x to the n, we're going to do that one first. And that's what happens when you take, let's do a quick example here. If I had 2 to the second power times 2 to the third power, the 2 to the second power means it's 2 times 2, and 2 to the third power means it's 2 times itself 3 times. And so you can see then that the total is 2 times 2 times 2 times 2, or 2 to the fifth. And so what do you do with 2 plus 3, or 2 and 3? You add them. And so the rule is when you have like bases, x to the m times x to the nth, that's the same as x to the m plus n power. And so over here in this numeric example, we've got 5 to the second power times 5 to the sixth power, and that's 5 to the 2 plus 6, or 5 to the eighth power. And if you evaluate that 5 to the eighth power, that's equal to 390,625. All right, and let's continue on down just one here. We've got x to the m divided by x to the n power. So you've got like bases, you're dividing them. And so we've got, that's equal to, just like multiplication, let me do a quick example before. Like if I had 2 to the fifth power divided by 2 squared. Well, 2 to the fifth is 2 times itself 5 times, or 2 times 2 times 2 times 2, 5 times there. And then 2 squared is 2 times 2. Well, this 2 cancels this 2, leaving 1. This 2 cancels this 2, leaving 1. And what you're left with is 2 multiplied by itself 3 times, or 2 to the third power. So how do you get that 2 to the third power? You take 5 and 2 and you subtract them. And so the rule is x to the m divided by x to the n is x to the m minus n. It's always the top exponent minus the bottom exponent, the exponent of the base. And so that then is the rule. So over here, this is 4 to the 8 minus 3, which is 4 to the fifth power, and that as a number is equal to 1,024. All right, let's go back up to the top. Look at what happens when we have 0 exponents. So the idea of 0 exponents, let's say we had 2 to the third power, and we divide it by 2 to the third power. So when you divide like bases, you subtract the exponent. So that's the same as 2 to the 3 minus 3. But 3 minus 3, that's 0, 2 to the 0. Well, another way to think about 2 to the third is that it's 2 times 2 times 2, which is 8. And so you have 8, and then you have got it divided by 2 to the third power, which is also 8. And 8 divided by 8 is 1. And so if you raise a number to the 0 power, you get 1. with one exception. You cannot divide by 0, and so it is important that you note that the x cannot be equal to 0. Your base cannot be equal to 0. And so over here in this example, let's see, what number would that even be here? 1,234,567,890 raised to the 0 power. It's just 1. All right, x to the minus n. X to the minus n, again, let's do a quick example here. If I have 2 to the second power divided by 2 to the fifth power, that's 2 to the 2 minus 5. Well, 2 to the minus 5, that's 2 minus 3. I'm sorry, 2 to the 2 minus 5 power. 2 minus 5 is negative 3. So you've got 2 to the negative third power. Well, again, another way to think about this is that's 2 times 2 in the numerator, and in the denominator, 2 times 2 times 2 times 2 times 2, or 5 times. So then these cancel because they're equal to 1. These cancel because they're equal to 1. So we leave a 1 in the numerator, and in the denominator we have 1 over 2 times 2 times 2, which is 1 over 2 to the third power. And so that's x to the minus n is equal to 1 over x to the nth power. And once again, because you cannot divide by 0, it is important to note your base cannot be equal to 0. So that's x cannot be equal to 0. 3 to the minus 4 power is the same as 1 over 3 to the fourth power. And that's, as we noted up here, 3 to the fourth power is 81. So this is 1 over 1 over 81. And then we have 1 over x to the minus n. Now, if it's negative in the numerator, as we see in this case, it becomes positive down in the denominator. Well, if it's negative down here in the denominator, then it becomes positive. We've got x to the just regular n power up in the numerator. And so let's see what that looks like over here in this example. 1 over 4 to the minus 2 is the same as 4 to the second power, and that would be 16. All right. And we're moving right along. So when we have a power of a power, I'm going to work through just a really quick example here. Like, let's say I had 2 to the second power raised to the third power. Well, that'd be the same as 2 squared, because that's the base. This right here is the base. The exponent is 3. So that's 2 squared times 2 squared times 2 squared multiplied by itself 3 times. But now I use the rule that says when I multiply like bases, I add the exponents. So 2 plus 2 is 4, plus 2 is 6. So this is 2 to the sixth power. And what did we do with this 2 and this 3 to get 6? We multiply them. So the rule is we take x to the m times n power, which can also just be written as x to the mn, which mn means m times n. So over here, we get 7 squared raised to the third power. That's 7 to the 2 times 3 power, or 7 to the sixth power, which is equal to 117,649. All right. This next one, we're going to write out the rule. If you have some things multiplied inside, let's say a times b raised to the m power, that's the same as a to the m times b to the m power. Both of them get raised to that power. So over here, we get 6 to the third power and x to the 2 times 3 power, or and 6 to the third power is 6 times 6 times 6, which is 216. And 2 times 3 is 6, so this is x to the 6th power. And then that would be your final answer. Sometimes students want to keep multiplying that 6 by the 216. The 6 on this exponent, let me put a little color to that. This 6 applies only to the x, not to the 216. Okay? Keep that straight. All right, let's take a look at the next one here. If you've got a quotient, x divided by y, raised to the power m, that's the same as x to the m power divided by y to the m power. And again, it's important that y is not 0, because you can't divide by 0. So over here, we've got this 3/4 to the second power. That's the same as 3 to the second power, and 4 to the second power. And 3 squared is 9, and 4 squared is 16. And that would be your answer after you've evaluated that. And then finally, if I have a quotient like a divided by b raised to a negative power, let's say negative m, that's the same as, and you can just flip them, b over a raised to the m power. So getting rid of the negative in the exponent just switches your numerator and denominator. And so then you can say, well, this is equal to b to the m over a to the m. And so over here I get 10 over x raised to the negative 2 power. That's the same as x over 10 raised to the second power, which is x to the second power, 10 to the second power, or x squared over 10 squared is 100. All right, there you go. You're going to have a chance to practice some of those properties on your own. Good luck, and have fun.